So once you've got your lovely vertical lines in there, that first piece, first thing I do is just kind of read it. Now, the way I typed all these out, it doesn't have to come in order, but I typed them out this way on my paper. So like the first piece should be the far left, the one in the middle should be the one in the middle, and then the third piece will be on the right side. All right, so if you read the inequalities, that'll match up with what I just said. But this says x is less than -3, so this would be, whoops, left of -3. The middle piece says x is between -3 and 4, so literally that piece is going to be between -3 and 4. And then the last piece, greater than, goes to the right, so it says x is greater than or equal to 4. This is going to be on the right of 4. So all those vertical lines we just drew in the graph, just drew x equals -3 little dotted line and x equals 4 little dotted line. Those are where the pieces will switch. Okay, now here's what I'm going to do. For the first piece, I'm going to make a little table. So I'm going to write x, and I'm going to write x plus 2, because that's the little rule for that part of the graph. Now, what I would always tell you to do, start your little table with whatever that number is in the inequality. So that says x value is less than -3. So I just start my table with -3. And then you don't have to do this, but I usually make a little note for myself, and I'm like, okay, should that be at that place an open circle or a closed circle where it touches that boundary line there? So this is x is less than 3. So I just make a little note to myself that that should be an open circle. And then everything else you could just do a filled in circle, but I should not actually touch the line at that point, so you'll see an open circle there. Okay, now, to make more points on the graph, all I need are x values less than 3. And this throws people off for the less than a lot of the time. So just think of this, look at your x-axis, numbers less than 3 or -3 would go to the left. So like I could do like -4, -5, whatever. And that this rule's pretty quick, so I could just, if you wanted to just plug the numbers in there real quick, like -3 plus 2 is -1. -4 plus 2 is -2. -5 plus 2 is -3. And just make sure we're using x values to the left, and then that first piece should point to the left when you draw it. So I just come over to the graph. So -3, -1, a little open circle because I don't actually touch that point, but it would be part of the graph. And then I just plot some points. So -4, -2, -5, -3. And it should just keep going down one, over one, backwards like that. And I just draw a little ray, point to the left, because it's all the x values that are less than -3, and that should be my first piece. The middle piece, now, as long as this is a line, what I do, the middle piece is actually not even something I can plug it into. It just says it's -5. So no matter what my x value is, if I plug it in there, there's no x to actually plug it in, so my answer or my output would just be -5. What I use is, as long as it's a line, if it's a parabola, or absolute value or something like that, I would graph more points in between. But if it's just a line, I just do those two boundary lines, so -3 and 4, and I'll just play connect the dots because it's just a line. Now, look at your inequality symbols. -3, it says x is greater than or equal to -3, so that circle would be filled in solid. And then it says x is less than 4, so when I get to that point, I should have an open circle because it doesn't actually touch that point. But then in terms of the table, it would literally just be -5 for each one of those. All right, so I'm going to play connect the dots here. So just -3, -5, and that should be on that vertical boundary line between the pieces, and that circle is going to be filled in. And your 4, -5, that one will be an open circle. And we're just going to play connect the dots. This should be a horizontal line. All the y coordinates in between those two should be the same. They should all be -5. And notice that the pieces don't overlap. Like one line does not go into the boundary of the other line. So they should not overlap. If you do, then you did something wrong. And then the last piece is -1/2 x minus 2. Now, that should go to the right of 4. So here's 4. So I always start my table with the boundary line. This is greater than or equal to, so to be a solid filled-in circle. And then to keep going with my table, I just need numbers bigger than 4. So I want to go this way. Now, I would not probably pick 5. Does anybody know why? Like, why would I not want to plug in 5? You not sure? It would. I mean, you could do it, but it's not going to be a nice number because, like, -1/2 times 5 is not. It's going to be a decimal. So if you got a slope that's a fraction, I would just plug in numbers that are like, as long as they're divisible by the denominator, should give you a nice value. Just make sure they're to the right of 4. So maybe I would do like 6 or 8. Okay, now let me show you how to do a little cheat with. No, I mean, use your resources with your calculator if you don't want to plug these in. Okay, so if you take your calculator, I'm just going to turn my calculator on real quick and show you how to get to this. I use this all the time. So if you just go to your y equals, and you might have something in there, so maybe just clear it out. I'm just going to type in the function rule, which is the -1/2 x minus 2. Now, very, very important. If you're doing a negative as your very first term, so I got -1/2, make sure you use the negative key under the 3. Don't use the subtraction sign because the calculator doesn't like that. So I'm just going to do -0.5 and then -2. Now when you do the -2, you want to use the subtraction key. But if you're, oh, I didn't put an x, fired. Okay, put an x before you put the -2. And then, but just make sure the negative key has to be used if that first term is a negative in front of it instead of the subtraction sign, or it won't do it right. Okay, now, do you guys know how to get to the table? Have we done tables before? Okay, I'm going to give you a little, it's easy. Just second and then the graph button. You'll see the table is that function there. Just hit second graph, and that should give you a full table for that equation. And you can just use your buttons to scroll up and down if you want. So we wanted to start at 4, and then I did like 6 and 8 just so I'd have nice points to plot, but I'm literally just going to copy that real quick. So at 4 you should be at -4, at 6 you should be at -5, and at 8 you should be -6. And again, I just picked those x values so I wasn't estimating if I could. You just need a couple points to play connect the dots to draw your line. It should point to the right. So for -4, I'm going to have a filled in circle. 6, -5, I'm going to put that point. 8, -6. And then we're just going to play connect the dots, and it should be an array that points to the right, because it's only for the x values to the right of 4. So the graph would look something like that. Is anybody having a question? Is anybody's table messed up? I had somebody's table that was really messed up last period. Is your table messed up?
Mine's gonna be like -36.13.
Okay. No, that's it. It's a trait number. So, okay. Is anybody else's table messed up? Okay. I'm going to be happy to show you how to get to the setting to fix that. Okay, so I'm just going to try one more with you with lines. And then on the back, I actually have one with a parabola, so I want to show you how to do that too. Okay, so I have 3 pieces to this question also. And we're switching over at -2 and +3. So at -2, I'm just going to draw a nice vertexal line. That'll be where I want to stop my first piece. My second piece is going to be between that vertical line and another vertexal line at 3. And so I'm splitting my graph into the 3 pieces. No, you don't have to do the tables. Like I said, some people like to draw the lines in arrays. If you guys want to, here, let's do this one like that. I'll tell you what. Okay. So, if I just wanted to graph the line, like y equals -x minus 4. Okay. Now, this would just be on the left side of -2. So if you were just like, okay, I want to graph this line, I'll just show you this in a different way. If you want to use the table, use the table. If you want to use this, use this. Okay, so I would start at -4, and I would go down 1 over 1. But if I'm doing that, that's going the wrong direction. All right, so if I start at -4, I'm actually going to go backwards. So I'm going to go up 1 over 1 to the left. That's still a negative slope. Up 1 over 1 to the left. Okay, when I'm at -2, that should be an open circle right there because it just says for x values less than -2. And then I'm just going to keep going. I'm going up 1 but left 1. So that gives me that slope of -1. Up 1, left 1. And if you want to do it like that, just only play connect the dots on the left side of that boundary line. So if you want to graph it like that, that is perfectly fine instead of making a table. If you want to just kind of start at the y-axis, now that one I have to kind of go backwards from what you're typically used to. Usually you do rise over run, you go down 1 over 1 to the right, but if I go up and left, that goes back the direction I need it to go. Now, the one in the middle, if I was just graphing that normal line, right? So this is going to be between the -2 and 3. Now, this is 2x plus 1, right? We'd start at 1, and I would go ahead and plot that point, because that's in between where I need to be for that piece. And then I would just go up 2 over 1, up 2 over 1. Now, when I hit that boundary line, that's where I want to look at the inequality symbol. So at 3, it would be a filled in circle. So I'm going to go ahead and fill that in. The only other thing I would do real quick is that piece has to go back and be between the -2 and the 3. So I would actually want to go backwards with this too. So I go down 2 over 1 to the right, or to the left, sorry, down 2 over 1 to the right. That would connect back at, what is this fuzz doing? Okay, -2, -3. So if you don't like the table, you could do it like that, and you do not have to get a straight edge out. I'm just getting my contractor out real quick so I can draw a nice line because I'm not very good at it sometimes. And if you want to do that, you totally can. Now, the third piece is just 6. So if it's just a number, you're going to have a nice horizontal line at that number. And so this is going to go to the right of 3. Now, at 3, if I go up to 6, I would have an open circle on the 6 because it just says x value is greater than 3. And then it would be like 4, 6, 5, 6, 6, 6. If I make a table, it should point to the right. So if you don't want to make a table, if you want to just do the graph like that, that's totally fine with me. Just make sure none of the pieces overlap. If you like the table, make yourself a little table for each piece. That's totally fine as well. That looks like that doesn't connect, sorry. So, is anybody having a question? I'm not trying to confuse you. Okay. Now, if I was doing this next graph, the next graph does have a parabola in it, and it's not written in vertex form, so it's not super easy for me to just be like, okay, here's the vertex, I'm going to use my 1, 3, 5 or whatever. So for that particular question, I would probably recommend using the table on your calculator for that first piece, but that's just me. And if you want to plug stuff in, you can, or if you want to go ahead and find the vertex and all that. But for that parabola, what I would do is I would use the table. Okay, so I'm going to use the parabola on the left side of -1. So I'll tell you what, I'm just going to write out a table here for this one. So for x values less than -1. Now, if I'm doing a parabola, if you have a line, you can just play connect the dots, right? If you're doing a parabola, I would do more points so you could see where the vertex is at and things like that. But I always start my table with that boundary number because it's going to touch this line. Is it an open circle or a closed circle? For this one, it will be an open circle. So I don't actually go to that point, but I have an open circle on that point. Now, to the left of that would be stuff like -2, -3, -4. All right, and again, I would just recommend using the table, or you could plug numbers in if you want. But when you type this in, don't forget -x squared, put the negative key under the 3, then do your x squared, and then do just a -6x minus 4. And once you get it typed, just hit second graph, and that'll be the table. And then I'm going to scroll up a little bit here, because mine started at -1. Let's see. So -1's at 1. negative 2 is at 4, negative 3 is at 5, negative 4 is at 4, and I'm just going to write one more, negative 5 is at 1. Can you guys tell from looking at the table there what the vertex would be? How'd you know? Do you guys see, like, see how the y coordinates are like a mirror image, like 1 and then 3? But I mean, wouldn't have to notice that pattern, but like there's a 4 on either side of that, and then a 1 on either side of that, so that negative 3, 5 has to be the vertex. So I would come over to my graph. At negative 1, 1, we'd have an open circle. At negative 2, 4, you have a point. At negative 3, 5, you have a point. At negative 4, 4, and you can see this, like that'll be like the turn in the parabola, if that makes sense. And then it should just be over 1, down 3 from there, which is the point that I wrote from the table, negative 5, 1. But only connected up on the left side of that vertical boundary line there. So it would look something like that. Okay, now this graph is a little bit weirder than the ones on the front, but the next piece goes from negative 1 to 2. So we've already got the negative 1 in there. Let me just go to the 2. And you can make a table if you want, or if you want to draw the line, it's 2x plus 1. It's up to you. I'm just going to make a little table for mine here real quick. So 2x plus 1. And I usually just plug in the 2 numbers for the boundary lines in the domain. So negative 1 and 2. Both of those would be closed circles. And I'll just play connect the dots because this is just a line. If this in between, if it's a parabola or absolute value or something, you're going to want to get more points than just those 2. But since that's just a line, I'm going to play connect the dots. All right, so this would give me, let's see, negative 1, and this would give me 5. So I'm just going to plot those 2 points. Both of them would be closed circles. So negative 1, closed circle. And 2, 5, closed circle. And you do not have to do this. You can just sketch it the best you can. I'm just going to use my contractor real quick to make that really straight. But that piece would look like that. And then the third piece is just negative 5. So it should just be a horizontal line. So for that third piece, if you do want to make a table, it's for x values that are greater than 4. So I would always start with that boundary line. That'll be an open circle there. So maybe like 4, 5, 6. There's just nothing to plug into it. So all those y coordinates will just be negative 5. It should, I'm off the screen, forgive me. It should just create a horizontal line. So if I am, oh, that's what I was going to tell you. Now, that piece starts at 4, right? So there's actually a gap in the graph here where you don't have anything. In between the 2 and the 4, it's not defined here. So like if I told you to evaluate that function for 3, you'd have to tell me it's not defined because there's no graph in any of those pieces that's in between the 2 and the 4. And that's okay. They don't have to connect. There can be a gap. And so that piece, that third piece, does not start until you're on the right side of the 4. So when I do that, I'm going to go, let's see, I got 4, negative 5. So open circle for that one. And then the rest of them, you can just put dots or you can just go ahead and connect that. It should just be a ray that points to the right. So they don't have to necessarily match up with the boundary lines. There can be a gap, and that's what happens in that graph there. Does anybody have a question? Okay, the rest of this is evaluating, but yesterday we evaluated from a graph, and today I'm going to have you evaluate from an equation. All right, so this says equation for my piecewise is g of x, and then it gives you 3 pieces. And we want to find g of 10, g of 2, g of negative 4, and g of 3. So this is my piecewise function. Who can raise your hand and just tell me, like, how would you figure out g of 10? Like, what would you do if you don't have a graph, if you just have the function? What would you do with the 10? Exactly. Okay. So remember, this is your x value. So for this one, we're going to pick the bottom equation. You basically have to figure out which category does it fall into. Okay, so is the number 1 or smaller than 1? That would be the first piece. Is the number bigger than 1 and less than 3? Or is the number 3 or bigger? So then you got to figure out the piece. So 10 obviously would fall into that category. So that's where you would plug it in. So for that third piece, you would just do 6 minus 2 times 10. I'm using the third piece because 10 is bigger than 3. So it'd be 6 minus 20, so negative 14 would be the actual answer there. You're just going to plug it into the piece where the x value would fall. Okay, so which one would 2 fall into? Would you use the first one, the second one, or the third one if you were trying to plug in an x value of 2? The second one, right, because 2 is between 1 and 3. Now, that one, you literally just write down negative 10. There's no x for me to even plug it into. If we saw this on a graph, it would just be a horizontal line. So I just copy down the negative 10. That's all you have to do. Okay, first, second, or third, where would you put negative 4? The first one. Sometimes the or equal to, I don't know why throws people off, but negative 4, this is like 1 or smaller. So negative 4 is smaller than 1. So you would plug that in to that first piece. Okay, now here's another thing, just real quick. We have an absolute value here. It's 2 times absolute value of x plus 1. We are going to put negative 4 in place of x if we're evaluating this at negative 4. Okay, don't just be like, oh, it's an absolute value and change that to positive 4. It doesn't work that way. What you have to do, absolute values act like parentheses. So before you take the absolute value, you have to simplify whatever's in there first. All right, so don't just change that to a positive 4 because it's an absolute value. You get the answer, it'll be a little bit off. So take negative 4 plus 1, which would be negative 3. Once you have that down to one number, then you take the absolute value. So this ends up being 2 times 3, which is 6. So just be careful with that. Get absolute values down to one number, and then it makes it positive once you've got it simplified to one number on the inside of the absolute value. If it's already positive, it stays positive. If it's negative, it becomes positive. Okay, first, second, or third, where would you plug in 3? The third one. Okay, so this is actually equal to 3, so you got to use that third piece. So then you're just going to plug in, just use that part of the rule. So 6 minus 2x, in place of x, you'd put the 3. This actually just ends up being 6 minus 6. So the function there evaluated at 3 would be 0. All right, so remember, in the parentheses, that's your x value. You're telling me the output, which would be what you would get if you plug that x value into whichever piece it should be plugged into. Does anybody have a question? Now, at the very bottom, this is not piecewise. This is just evaluating functions from the 3 different formats that we've done in class so far. So the first one is just f of x is a function rule, just a straight up equation. The second one, I don't think we've done anything like this in class. I think there may have been a question on the Math Excel where it gave you a table. And then the third one, we've done a little bit with evaluating from a graph with the piecewise and with the Math Excel. So 3 different things going on, all the 3 different formats you could evaluate from. So I'm just going to answer the question. So like f of 2, you're just going to plug 2 into the actual function rule, figure out what that is, right? So if I do 2 times negative 2, that would be negative 4 plus 5, so this will just be 1. And then h of x is the graph. So if I, just raise your hand and tell me if you think you can figure this number out. If I did h of 2 and I'm looking at the graph, what would my h of 2 be from that graph? What do you think? Should be 0. You just find the x value and meet the graph. In that particular case, the graph is actually touching the x-axis, so the y-coordinate there would be 0. My actual answer to the question then would end up being 1. 1 plus 0 is 1. All right, we haven't done operations for a minute, so if you guys remember, this notation, f divided by g of 8, means f of 8 divided by g of 8. So for the f of x, we're just going to plug it into the little rule. So everywhere I see an x, I'm going to plug in 8. So if I did negative 2 times 8, we'd get what? Negative 16 plus 5. So the top of that would be negative 11. Okay, now we haven't done much with the tables, but g of 8, we'll use the g of x function. So that's that table there. How would you go about finding g of 8 from the table? Anybody know what to do with the table? Like, what do I, or what, tell me what it is if you figure it out. What would g of 8 be? What do you think? Negative 14. Okay, again, this is your x value. So I'm saying my x value is 8. You just tell me the corresponding y value from the table, so that would be negative 14. All you can do there is the two negatives will cancel out. That fraction doesn't reduce or anything, so just be 11 over 14. All right, let's see if I can move this up just a little bit. Okay, h of 6. So if I look at the graph, I'm telling you my x-coordinate's 6. What would you tell me h of 6 is from the graph? Can you tell? What would h of 6 be from the graph? It should be negative 8. Here's 6. You got to meet the graph. It would be this point right down here. So it'd be 6, negative 8. So negative 8 is what h of 6 would be equal to. What would you guys tell me for g of 6? That's going to use the table. Perfect. Okay, and then we're just supposed to multiply together. So negative 8, negative 11 multiplied give you positive 88. Now, the last one is not multiplication, and I know we haven't done this for a couple days. The last one is composition, so that's 2 problems in 1. So you're going to work from the inside out. So I need to start with h of 0. So h is the graph. Can you tell me if I did the graph evaluated at 0, what would you write down as your answer? Negative 2. Good deal. So 0 is my x value. Just meet the graph. That's at negative 2. So there's where you go there. Now, when you're doing composition, remember it's 2 problems in 1. So once you get this h of 0 that's equal to negative 2, then you're going to take negative 2 and plug that into the f of x function, which is just that function rule there at the top. That will actually be my answer to the question. So f of negative 2, just come up here. Negative 2 times negative 2 would be 4, plus 5 would end up being 9. 9 is the actual answer to the question. You have to do the h of 0 is negative 2 to get that first step to figure out what number to plug in. But 9 is going to be the answer for that last one. Okay.